can see you there. I bet you're here to learn about probability and statistics. That's excellent. You're in luck. Let's start. What do we have here, Luca?
I see.
Struggling with stats again, are we?
Yeah, actually, mate, I don't know what any of these words mean. What's a random variable?
Wow, Luca, you're very silly. Let me tell you. Everyone knows that a random variable is a function going from the set of all possible outcomes, omega, to the real measurable space, usually denoted by r.
What are you looking at?
Wait. Now let's look at a more formal definition. Wow, that looks horrible, guys.
How did you do that?
I don't know. So, let's see if we can simplify things a little bit, Luca. Essentially, a random variable is a variable whose possible values are values that are numerical, that are outcomes of a random process. Did you know that, Luca?
So it's not a traditional random variable in the same sense as in standard algebra, but instead a way to map outcomes of a random process to numbers. A function where the set of possible outcomes is a domain, and the real numbers are the codomain.
Exactly, mate. Let's have an example. If we take this coin, for example. When I flip this coin, there's two possible outcomes, heads or tails. And we can model this with a Bernoulli distribution. Would you like that? Bernoulli distribution? Don't worry, we'll get to that later.
Then we could say that the random variable equals 1 if it's heads and 0 if it's tails.
Absolutely.
So the random variable x takes the outcome heads and maps it to 1, and takes the outcome tails and maps it to 0, right?
Hello again. Let's talk about probability distribution functions. Simply put, a probability distribution function, or commonly known as PDF, is just a function that takes every subset of the sample space and assigns it a value between 0 and 1. In other words, it takes each possible event and assigns it a probability that it will occur. Don't forget that the probability of all the events happening is equal to 1, and the probability that none of the events happen is equal to 0. So there are two types of probability distribution functions. There's discrete and continuous. Discrete are modeled by mass functions, and continuous are modeled by density functions. So we can use mass functions to find cumulative distribution functions. When a random variable x is evaluated at a value t, the cumulative distribution function gives the probability that x is less than or equal to t. As such. We write this equation as a sum of the probabilities that x takes each value less than or equal to t. Looking good, guys.
No team.
Crushed it.
Yeah.
Oh, hello friends. I see you're playing beer pong.
I forgot to invite him.
This is like a great opportunity to talk about standard discrete models. Let's start with Bernoulli random variables. These only have two possible outcomes, success and failure, which map to 0 and 1. The Bernoulli distribution has only one parameter, the probability p, and the function. It's going to be here somewhere. Let's say the probability that Luca successfully throws the ball into the cup is 0.4, then p is 0.4. So the probability of success is... Let's test that.
I really don't.
Just throw the ball, Luca. Just throw it. It's like the probability should be a bit lower, Luca.
Why are you doing this to us?
Let's try another distribution. How about binomial? In a binomial distribution, X models the number of successes in a certain number of independent and identically distributed Bernoulli trials. This distribution has parameters P, probability of success, and N, the number of trials. This distribution function is a bit more complicated. Now let's say the probability that Rebecca...
My name is Rachel.
Let's say that the probability that Rachel gets this ball in one of these cups is 0.65.
I'll give you 15 shots and I'll only take 10.
Who is more likely to get all 6 cups? If you said Luca, then you're completely wrong. Take a look at the maths above.
That's actually pretty cool.
Don't encourage him.
But wait, there's more.
Please, no.
A binomial but with only one success, geometric distribution measures the amount of Bernoulli trials that take place before an outcome occurs. Its parameter P represents the probability of success, and its function is simply given by... What's that, you asked? The probability that Rachel takes 7 attempts to get a ball in.
Literally nobody asked that.
Shut up, Luca. The answer is really small, so don't get your hopes up, Rach.
Great. Can we get drunk now?
Finally, we have the Poisson distribution, which is great for modelling things that occur within a fixed interval of time, area, volume, or pretty much anything really. In this case, our parameter is lambda, which is the average rate with which an event occurs. For example, let's say 1 in every 10 cans of beer is flat. If I go to the shop and buy 10 beers, what's the probability that at least one of them will be flat? Perfect. So there you have it. Stats is fun. You kids have fun now too. Luca, that's actually really cold, mate.